All right, so today what we're going to do is we're going to look at section 3D. We're going to talk about circles. Now, the reason circles are always treated separately from other geometric shapes is that they behave a little bit differently and their measurements are a little bit different, etc. So the first thing we want to do is we want to talk about the basic measurements of a circle. So if you have a circle, you can have a line that extends all the way across through the center, and that line is called the diameter of the circle. So diameter is the distance through the center to the edges. Right? And it's generally denoted with a lowercase d. You can also have a line that starts at the center and goes to one edge, and that one is called the radius. And the radius can simply be defined as half the diameter. And it's important that you establish that relationship between the two because you're going to see that some formulas use the radius, some formulas use the diameter, and generally what they like to do to you is if you need the radius, they give you the diameter. If you need the diameter, they give you the radius. Okay? So they break it up. And finally, the last one is something called the circumference. The circumference of a circle simply means the distance around. Circles don't have sides, they have edges, so you can't have a perimeter because that's a measurement of the sides. And so instead you have what's called the circumference. Now, a couple of formulas that we need for the circle. The first one is we need a formula for area. And the formula for area, you've seen 1,000 times before. Area equals pi r squared, where r is the radius. Pi is a relationship that you don't need to really define because you have a calculator keystroke that will give you pi. What I do not want you to do is just round it to 3.14 and use that as a calculation. You need to use the pi key on your calculator in order to be able to do these because it will affect the final answer if you round it too soon. Okay? So we'll get in the habit of and used to using the pi key for these. The second one is the circumference. And the formula for circumference can be given in two different ways, depending on if you know the radius or if you know the diameter. The easiest one is simply circumference equals pi times diameter. And you can use that if they give you the radius as well. You'd simply take the radius and what? Double it, right? Okay? Or, if you have the radius, you could use circumference equals 2 pi times the radius. Because 2 radii make 1 diameter. Yeah? So either way you use it, it doesn't make any difference. Okay? And again, make sure you use the keystrokes in your calculator when you're working with these using pi, the pi key, instead of 3.14 or some other approximation. The only trouble that you could run into when you're working with circles is making sure you know the calculator keystrokes so that you get the correct answer, because the order of operations is going to make a big difference. Now, some of you are just going to type in the whole thing at one time. Perfectly fine, makes no difference to me. But as we move forward, you're going to see that there are going to be some formulas where your calculator not in this section. They're pretty easy to use. But some formulas that, for some reason, some of your calculators, even if they're exactly the same brand, one of you will be able to get the answer by typing in the whole formula at one time, and the person next to you may not. It's just a quirk of these calculators that they don't always return the correct answer if you type in a whole long set of formulas, lots of brackets, etc. Okay? So be careful. Make sure that you check your answer against the answer in the book or on the computer to make sure that your calculator, if you're typing in the whole thing at one time. If not, you can just use the order of operations. For example, on this one, pi r squared, first I'd have to take the r and raise it to the second power, and then multiply times pi. You also want to make sure that you don't clear it and round it as you go. You'll always round your final answer, but do not round until you get to that final answer. Okay? So make sure you know the right keystrokes to use to complete the order of operations, and that you don't round until the very end. Okay? If you'll notice on your formula sheet that I just gave you, that all of the circle formulas are always there. They're less likely to give you formulas for other basic shapes, though there are some for area here, but they always give you any formula that involves a circle. Okay? Now, those are the basic measurements and things that we're going to be working with circles, but there's some others that you're going to need to know as well. And the next one is something that is not on the formula sheet. So it's a formula that you're going to have to memorize. And it's not an incredibly easy formula for some people to memorize. What we're going to be doing is we're going to be looking at something called arc length. Arc length is simply, if you take a circle and you have 2 points on that circle, this distance between those 2 points is the arc length. We're looking for the length of that piece of the circle, that arc. Okay? And it's generally, for some reason I have no idea, called S. Now we've seen S before, though. S is also used in Heron's rule. There's no rhyme or reason. I have no earthly idea why. It's just called S. Now, when you're finding arc length, you're going to need to know the radius. And if you think about what happens here, if you have a circle, any point from that center to the edge is always going to be exactly the same length, because it's in the center going to the edge, and the edges are always equal distance apart from the center. So if you have 2 radii going from the center, those 2 values are always going to be the same. So if you know the radius, then you know the length of that piece of the circle. And between these 2, you get some angle. And the symbol that I just drew there is the Greek letter theta. Theta always stands for some unknown angle. So some angle can be any angle. We just use that symbol because we use letters for lengths and lots of other things. So we use the Greek letters when we start talking about the angles. And you've seen that before when you've looked at angles, right? So the formula for finding arc length, it's really easy to use, but it's a little unusual when you're looking at it. S equals, and S always stands for arc length, R, which is always the radius, times theta, which is whatever the angle is, so they have to give you that angle measurement, divided by 180 times pi. And the reason it's 180 instead of 360 is, in reality, it's theta over 360 times 2 pi, but the 2 and the 360 will simplify. And so that's why, even though you're dealing with a circle, normally you'd have 360. They've already simplified it for you. So that's why it's 180 in the bottom. Now, again, this formula is not given to you on your formula sheet, so we will have to practice it so that you'll remember what it's going to be. So we'll look at some examples, and we'll also remind you closer to the time when we take the test. You're also going to see, so all you need to do is plug in the information given into the formula and work it out. You're also going to see the word subtend. Don't worry about that. It just means that that's the angle where the two rays meet. And you don't even have to write it down if you don't want to, because you're never going to be asked the definition of it, but you are going to see that phrase or that word in the problems. You're going to see that the angle what is the measure of the arc that subtends the angle at 90 degrees? Okay? Or the circle at 90 degrees. So what that means is that these two rays here are cutting that circle into smaller pieces. Again, don't worry too much about the word. I just don't want you to be caught off when you see the word, when you see subtend. I don't know what subtend means. I can't make it work. The key to this is that phrase right there, arc length. Okay? So don't get caught up with subtend. And finally, the last thing is that we're going to look at deals with the classic circle word problem. And that is when you're dealing with an annulus. When you're talking about an annulus, what you're talking about here is two circles where one is right in the middle of another. Okay? So two circles with the same center. All right? So you have a larger circle and a smaller circle. And what you're going to be asked to do is you want to find the area of an annulus. So all you need to do is first find the area of both circles. Then simply subtract the larger one minus the smaller one. So the larger area, just subtract the smaller area from it, and that will give you the area of that space around. Okay. Brats. All right. Now, what's really important, though, is that you need to round and watch your units. This is an area, so it's going to be measured in what kind of units? Square units, you bet. So keep that in mind. Anytime you're dealing with area, it's always square units. You might also occasionally see a problem where it's given to you, the answer is in centimeters squared, but they want it in meters squared, so be prepared to convert it using those conversion factors that we learned in an earlier chapter. Okay. All right. So what we're going to do is we're just going to pop over to the book and look at a few of these. We'll do a couple of them together, and then I'll let you do some, and we'll ask and then answer questions. For our homework for this section, just put it on another page. For the homework for this section, we're going to do 1, 2, 3, 4, 5, and 9. It's on your list, but now you have it twice. So we found the circumference by using the circumference formula. The other part that they want you to find is the area. Again, so area equals pi r squared. Sorry, I'm getting carried away with my formulas. Pi r squared. So all I need is the radius, which is 5. So pi times 5 squared. And again, make sure you do the order of operations. So 5 squared first. So that's 25 times pi. Someone want to give me that to one decimal place, please? 78.5. Sorry? 78.5. And that's centimeters what? Squared. All right. Is this good? Okay, let's look at a few more.